Assalamu alaikum, welcome to Turkish Engineering. In this lecture, we are going to solve a problem related to units of a reaction rate, because sometimes we can represent it in terms of partial pressures and sometimes in terms of concentration. So it is good to understand how do we switch between them. So at the beginning, we have like unknown unit, okay? Here you have a value, but this coefficient has some units, okay? 3.66 watt. I don't know the unit. Let's say like a line. I don't know this. When I multiply it by pressure square, let's say ATM for the partial pressure, that will give me ATM per hour. So this unknown line of my units, if you send this guy to other side, it will be ATM per ATM squared hour, which will give me 1 over ATM hour. Okay, so I can understand now my unit is 1 over ATM hour. So it's done. Let's go to part B. For part B, we need to convert the units, okay, and find this K unit. So it is just, let's understand this. Na over V is just the concentration. So it is like concentration rate is equal to KCA squared, okay? And we have other thing here, PA. If we need to convert PA to CA, we can like relate it with the ideal gas law, number A, RT. So let's say PA is equal to number of A over volume RT. And this is just the concentration, okay, CART. So we can rearrange our concentration rate in terms of this again, 3.66, and I know the units, which is 1 over ATM hour times PA squared, okay? PA squared is just CART squared, okay? And this should be equal to, if you convert PA, minus D CART over DT. Like we have like isothermal condition, right? We are like this rate is a function of temperature. For that specific temperature, it's not changing by time. You can like send them outside of the derivative. So this RT can go to other side. Okay, so and I am searching for dCA dt, okay, which is equal to K times CA squared, right? I'm searching for this coefficient as value and also units. So in order to get this, I can use this equation and leave this alone. So you will just send RT to other side, okay? So 3.66, 1 over ATM hour, CA, you can say square, RT square, CA square, R square, T square. And here you have RT coming like this. So this cancel the squares. You have CA square RT. If you rearrange and cancel some things here again, you have CA square here and you have another CA square. So this K is nothing, just this coefficient multiplied by RT, okay? You can use anything in terms of ideal gas constant, because it will affect units. It will give you some number and it will give you a unit. So anything you can use, but ATM based version will cancel the ATM, so it is more convenient to use. 0.0821 ATM liter per mole Kelvin, okay? Multiply, this is R, and multiplied by 400 Kelvin. So some things will cancel each other, Kelvin with Kelvin, ATM with ATM. So you have, you can calculate this. I think we have 400, not square, just 400. Okay, so we have 120 liter per hour mole, okay? But if you see here, our equation says that it is mole per meter cube second. It is good to leave it like this, but if we need to convert in terms of meter cube and seconds, it's better. So let's convert one more step. So liter here, you can say 1,000 liter is 1 meter cube, and 3,000. Okay, so I can say 1 hour is just 3,600 seconds. So hour with hour, liter with liter, they will cancel each other. You will end up with this value. So you will get 3 times, let's say 1, 2, 3, 4, 5. It's 3.33. It's like this times 10 to the power minus 5 meter cube. You have over mole second. Okay, and let's cross check. If you, this is K, if you multiply it by CA squared, do you get this unit? CA squared is just mole squared over meter cube squared times S squared. Okay? If we multiply this by this, do we get the unit like above or not? Let's see. This meter cube will cancel this. Mole will cancel this. And second will cancel. Okay, let's see why this second is here. Okay. Mole per meter cube second square. Okay, mole per meter cube. But here second cube I should get. So I had a mistake. I don't know where, but liter per hour mole. Liter per hour mole. Okay. Then here second is below, so meter cube per mole second, mole per meter cube second. I'm sorry. This is why the problem is just CA unit does not include this. CA square is just mole square over meter cube square. Okay, so we are okay. We don't have problem. So when you multiply those, you will get mole. Yes, some will cancel each other, and you have mole per meter cube times square second times second, which is this one. Okay, we double check, and we get the same unit. So our coefficient value should be this, and unit for the K. So this is K. Okay, K is 3.33 times 10 to the minus 5 meter cube per mole times second. This is the final answer. Thank you for watching.